Well, hey there, kiddos. I hope you weren't tired of my voice in the first video because now you are stuck with me. But today we are going over solving systems by graphing. So we've done substitution, we've done elimination, and now we get to do my favorite, which is graphing, because you get to see your answers on your calculator or on your graph. To solve it, we need both equations to be set into y equals mx plus b form, because this is the only form that your calculator understands. Y equals mx plus b. So whenever you put in your calculator, you go up to the y equals button, you'll be able to put in both equations and see where the lines intersect. So let's look at number 1 here. The first equation, y equals x minus 16, that's already in y equals mx plus b form. But the next one, we need to do something to it first to get it in the form we want. So what I'm going to do is subtract the 1/3 x from both sides here. And so now my new equation for the bottom is going to be y equals -1 minus 1/3 x, or if you put the x part first, it would be y equals -1/3 x minus 1. These are the same equations, they're just written in different forms. The thing you need to remember is slope is always the number that's in front of our x value here. So now, whenever you plug these into your calculator, we're going to plug in y equals x minus 16 into y1, and then we'll plug in y equals -1/3 x minus 1 into y2. So go ahead and pause the video, take a second, and graph them on your calculator. What you might also need to do is alter your window. So whenever we graph these lines, you'll see that you can't quite see the intersection. So click on your zoom button, and zoom fit won't work for this one because it's still a little weird. So go ahead and click zoom out, and then press enter again, and you'll see your lines zoom out there. So then after you have them zoomed out, you can go to the second trace button, and we're going to calculate the intersect is what we want for our solution. So your calculator asks you for your first curve, your second curve, and then your guess. And if you press enter along those, you'll end up with 11.25, comma, -4.75. So go ahead and check your lines and make sure that's where they intersect. If you didn't get that, be sure that you put it into your calculator right with both forms there. Next one we're looking at is number 3. We're going to skip 2 and jump straight to 3. This one doesn't have any equations that are already in slope-intercept form, so we're going to have to do something to both of them to put them that way. So if I look at this first one here, 4x minus 2y equals 4, the first thing I want to do is subtract 4x from both sides here. And so now that's going to give me -2y equals 4 minus 4x, or -4x plus 4. Remember, it's the same thing, they're just ordered differently there. Last step there is going to be dividing both sides by my -2, and whenever you do something to one side, you need to do it to every number in it, so it's going to be -4 divided by 2 on both of those. So then we have y equals, well, 4 divided by -2 gives me a -2, and a -4 divided by negative is going to give me a positive number. So I have -2 plus 2x, or if you rewrite it, it's y equals 2x minus 2. Remember, these are the same thing. Sometimes it just helps us to see what's the slope and what's the y-intercept. So now if I go down to my graph, and I graph this, we know that my b value of -2 is going to be where we begin, because b stands for begin, so I put my first dot at -2, and my slope is going to be 2x. Well, a slope of 2 is the same thing as a slope of 2 over 1, so I'm going to go up 2, and then over 1 to get my next point. I'm going to keep doing that to get the rest of the points for my line. So now whenever I connect these points to make my line, there's my first one. So now I need to put the second one in y equals form. This one's going to be a little bit easier. The only thing that we need to do is divide both sides by 2. So if I have y equals 4x divided by 2 is going to give me a 2x. Well, if you notice, there's no b value out here. We have a b value on the other one of -2. This one, if there's nothing written there, it's implied that the b value is 0. You don't have to write it, just understand that the y-intercept there is going to be 0. So now whenever I graph that one, my y-intercept of 0, so I'm going to start it at 0. And then now look at the slopes. We have a slope of 2x here and a slope of 2x here. And we know that if they have the same slope, the lines are going to be parallel. And we can double check just by graphing my points here. So I went up 2 over 1. And so here's both of my lines. Even though they're not the prettiest, you can tell that they have parallel slopes, and we know that parallel lines never touch. These lines can go on forever and ever and ever, and they're never going to touch the other line there. And if a solution is where these two lines touch, since they don't touch anywhere, we can say that there is no solution. Now let's jump over to the next example. On this, you're going to see tables down here. You have a graph, so you can just ignore these two tables down here. So again, the first thing we want to do is get both of these equations into y equals mx plus b form. So I'm going to start with this one on the left here. We need to move that x the other side, and it's a positive x, so I'm going to subtract it. And so then we'll have 2y equals negative x plus 4, or 4 minus x. And then for the last step, we divide both sides by 2. So I'm going to divide everything by 2, and I have y equals negative 1/2 x plus 2. Now for the second equation, a little bit easier again. I have 2x plus y equals 5. I just need to move that 2x the other side, so I'm going to subtract it. And I have my y equals negative 2x plus 5. So go ahead and pause the video, take a second, and graph those on your calculator. You'll also probably need to change your window again. So if you click Zoom and 6 for Zoom Standard, it'll bring up a regular window for you. So if we look at those two lines and you do your second trace intersect, you'll see that they intersect at 2, 1. So that one definitely has a solution there. Now we got number 5. So number 3 had no solution. Number 4 had one solution. So we're going to see what it looks like for 5. Same step again. I need to get both of them in my y equals mx plus b form. So if I have a 3x minus y here, I'm going to subtract 3x from both sides. And so I have negative y equals negative 3x plus 2. That's not a z, that's a 2. And then we'll divide both sides by negative 1 to get rid of that negative in front of the y there. So we have y equals a negative 3 divided by negative 1 gives me a positive 3x minus 2. So there's my first equation. And then for the second equation, we'll subtract 12x from both sides. And so that leaves us with negative 4y equals negative 12x plus 8. So now if I simplify that, I need to divide both sides by negative 4. So everything gets divided by negative 4, and I'm left with y equals negative 12 divided by negative 4 is positive 3x. 8 divided by 4 is negative 2. What do you notice? If we look at both of those equations, they're the exact same. So whenever we graph them, I have my y-intercept of negative 2. And I have a slope of 3, 1, 2, 3 over 1. So there's one line, and my second line is the exact same thing. So if both of those lines are on top of each other, they're intersecting at every single point. So we can say that that has infinite solutions. So now if we look at them again, if I have two lines with the same slope, but different y-intercepts, there's no solution. If I have two lines that have different slopes, they're going to have one solution. And then if I have the exact same line, they're going to be infinite solutions. So now let's skip past 6 and go right to 7. The LHHS soccer team is selling hats as a fundraiser. They contacted two companies. Hats Off charges a $50 design fee and $5 per hat. Top Stuff charges a $25 design fee and $6 per hat. Well, the key words that we want to notice here are the per hats. So if there's something like a design fee, they're going to be paying this one time, but they're going to be paying $5 for each hat. Same thing with Top Stuff, $25 once and $6 per hat. So whenever we write an equation on this, we'll start with Hats Off. Now this is going to be on your second page, even though it copied on our first page here. So Hats Off, we know, charged $50 of design fee, and so that's a one-time fee of $50. But it was $5 per hat, and that key word there of per means they're not just going to pay $5 once. It's going to be every time they purchase a hat, so we'll say 5 times X. And now if we think about that total amount, a $50 start fee and $5 per hat is going to be a total amount So we just say y equals 50 plus 5x. Now for Top Stuff, they have a $25 design fee, so we know they're going to be charging $25 once, but then $6 per hat, or for each hat. So remember those keywords to look for. So it'll be 25 plus 6x, and we'll say y equals. Now for your let statements there, let's look at what our variables mean. So in Hats Off and Top Stuff, if you look at the 5x and 6x, that x is representing each hat that they purchase. So for our let statements, in your box on your page, you'll write let x equal hats, and then y, if we think about it, 50 is a dollar amount and 5 is dollar amount, so y is going to be a total dollar amount. So we'll say let y equal total cost. So that's going to be in your let statement box on your page. And I'll copy that back down over here for let statements. So we said let x equal hats and let y equal total cost. And we just wrote down the systems of equations, so we can copy down that same system right here. So we said Hats Off, and I'll abbreviate it as HO. We said y equals 50 plus 5x. And then for Top Stuff, so I'll just say TS, we said y equals 25 plus 6x. And now it says, for how many hats will the cost be the same? What is the cost? Well, we're looking for a solution here for where the cost is the same. So go ahead and pause and graph both of these equations on your calculator. Y equals 50 plus 5x and 25 plus 6x. If you do your zoom fit, it might not show the whole graph, so you might have to do zoom fit first and then zoom out. So after you get that and you do your second trace intersect, it tells you that the solution to both of our equations ends up being 25, 175. Well, if we know that the 25 is x and the 175 is y, the question says, how many hats will the cost be the same? Well, hats is our x, and the graphs meet at x equals 25, so we can say 25 hats, they'd be the same. And then what is the cost? We know our y is our total cost, and our y is 175, so we could say they'd be $175. Now it says, explain when it is cheaper for the soccer team to use Top Stuff and when it is cheaper to use Hats Off. Well, if we look at our equations, I'm going to draw a small graph here. We know that Top Stuff starts at 25 and then kind of slowly goes up. And I'll abbreviate that TS. And then our Hats Off starts at 50 and then goes up here. And then they kind of meet right at that point there. And so that point is 25, 175. So I'll abbreviate that as Hats Off. So the question is asking, when is it cheaper to use Top Stuff and when is it cheaper to use Hats Off? Well, if I look at my graph, that Top Stuff line is going to be lower than the Hats Off line all the way up to the point where they meet. And then the Hats Off line, if we kind of extend that graph, that Hats Off line becomes a little bit cheaper than the TS line after it goes past the point. So to answer your question, when is it cheaper to use Top Stuff and when is it cheaper to use Hats Off, you can say Top Stuff is cheaper for less than 25 hats, which means Hats Off is cheaper greater than 25 hats. But that's all we've got for you. I hope you'll have a good evening. We'll see you tomorrow.